In this recording, we're going to look at the normal distribution. So first, let's start with the standard normal distribution. The standard normal distribution is the distribution with mean of 0 and standard deviation of 1. So here we're going to look at a few probability questions. So what's the probability that a standard normal random variable z is less than or equal to 1? In other words, we want to know the probability of being less than or equal to 1, this shaded area here in the red. So in our StatCrunch, we're going to go over, select Stat, go to Calculators, and select Normal. So in this normal calculator, the standard view is going to be less than or greater than. And if I click on Between, it'll trap it between two values. So in this case, we're looking at the probability of being less than or equal to 1. So all I would simply do, the mean is 0, standard deviation is 1. I would just change this less than or equal to 0 to less than or equal to 1, and then press compute, and it would find that the area to the left of 1, the probability of being less than or equal to 1, is 0.8413. All right, so now let's consider the next case. All right. Here we're looking at the probability that z is greater than or equal to 1. So we're looking for the probability here in the right tail. So all I would do here is just simply say greater than or equal to, and it's already set to greater than or equal to 1, and it calculated 0.1586, or 87 if we round. All right, what about finding the probability of being between two values? So what's the probability that z is between -2 and +2? So as I mentioned before, we'll press the Between tab up here, and it'll find the value between two values. So I'll just tell it to look for the area between -2 and +2, and press compute, and it finds that the area is 0.9545 if we round. So in this case, we were finding probabilities. We changed the left-hand side of this equation to figure out what the probability was on the right side. Now let's look at a couple of other kinds of problems. So the first case here, we're looking at the probability of being less than or equal to something is equal to 0.1. So in this case, I'm looking for the 10th percentile. I want the value at which 10% of the area, 0.10, is less than or equal to that value. So what is the value z such that 10% of the area is to the left? So over here I would press the Standard tab, and I want to do less than or equal to, and I know the probability on the right hand side is supposed to be 0.1. So I'm going to change the probability on the right hand side to be 0.1 and then press compute. And so what I find is at x, or at z equal to -1.28, I would actually have then a probability of 0.1 of being less than or equal to that. All right, what if we wanted the top 10%? Well, if we wanted the top 10%, well, we just wanted the probability that we're greater than or equal to some value would be equal to 0.1, compute, and I get a positive 1.28. This should not be surprising since the bell curve is symmetric about x equals 0, or in this case, z equals 0. So what if I wanted to trap the middle 95%? So if I want to trap the middle 95% between two values in an isometric way, I could press the Between. And so here I would just press the probability of 0.95 and press compute, and it would tell me how far left and right to go and trap the middle 95%. And that would be at -1.96 and +1.96. So everything we've done so far, we've been looking at the z values, or the standard normal distribution, mean 0, standard deviation 1. But the same thing can be done for any normal distribution with any mean and any standard deviation. So let's consider a normal distribution with a mean of 50 and a standard deviation of 10. Let's ask ourselves, what's the probability of being less than or equal to 60? So I would simply just go over here, change the mean to 50, standard deviation 10. I'm going to change it back to standard and do the probability of being less than or equal to a value. In this case, the value is 60. Press compute, and I find the probability to be 0.8413. All right, I could also look at a right tail probability. All right, what's the probability of being greater than or equal to 60? So I just simply change this to greater than or equal to 60, and I find the probability is 0.1587. And if you'll notice, the two probabilities here, one for less than 60 and the one for greater than 60, should add up to be equal to 1. 1 is the total area under the curve after all. Okay, so let's consider the probability being between two values. So again, I'd press the between tab, and the probability being between 30 and 70 would be essentially 0.95, 0.9545 in this case. So this is where they get that empirical rule that approximately 95% of all values will lie within 2 standard deviations of the mean. All right, looking at percentiles, here looking for the 10th percentile, what's the probability? What is the x value at which 10% of the area is left of the value? So probability that x less than or equal to some value is equal to 0.1. So probability being less than or equal to x is 0.1. So over here, I would choose standard, and I'm doing less than or equal to, and the probability is supposed to be equal to 0.1. And so in that case, I would compute that this x value then must be 37.18. If I wanted the top 10%, what value must I exceed? What x value has a probability of being greater than or equal to that x is equal to 0.1. So I would just change this to greater than or equal to, make sure the probability to the right here is 0.1. And so in this case, I get that the x value at which 10% of the area is to the right is equal to 62.82. And so I could have looked at the fact that if 10% of the area is greater than this x value, then 90% is less than the x value. And I simply could have just said less than or equal to being equal to 0.9, and that would have also given me the 62.82. All right, and one last thing, if we want to look at the probability, right, of 0.95 being trapped symmetrically about the center of this distribution, I could do between once again, and this time I don't know the boundaries, but I know the probability in the middle should be 0.95. And in this case, we get 30.4 and 69.6. So 95% of the values will lie between 30.4 and 69.6. So I hope this has helped a little bit on how to use StatCrunch to find some probabilities and some percentiles.